Good evening, everyone. My name is Namakula Josephine. I'm from Group 2, and today we were to select, review, and present a journal paper that aligns with our machine learning topic, which is interpretable machine learning techniques for students' performance prediction. So we reviewed a journal, and first of all, we were told to review a journal. So we review this journal, and its name was Multiclass Prediction Model for Students' Grade Prediction Using Machine Learning. It was published in IEEE Access, Volume 9. These are the pages, and the publication date was 30th June 2021. These are electronic ISSN, the publisher, and the DOI. So this is the funding agents, the authors and the affiliations of the journal which I am reviewing. So the keywords in the journal paper, one of all was machine learning. The second is predictive model, imbalance problem, students' grade prediction, and multi-class classification. And this is the link to the paper. So these are the citations. Our computation problem tackled by the authors. The paper addresses the problem of predicting students' grade in a multi-class classification scenario using machine learning techniques. It focuses on handling challenges such as imbalanced datasets and the need for accurate prediction models to improve education decision making. The machine learning models developed, they used a decision tree, J48. So the J48 algorithms, a variant of the C4.5 algorithm, was employed as a decision tree classifier. It was chosen for its ability to handle missing values and high-dimensional data effectively. The authors indicated that J48 was widely used in several multi-class classification scenarios and could provide optimum accuracy with a minimal number of features. So decision tree classifier had the highest accuracy of 88% compared to other categories of algorithms. So the second machine learning model was naive Bayes. Naive Bayes is a probabilistic classifier based on Bayes' theorem with the assumption of independence between features. It is known for its simplicity, speed, ability to handle small datasets effectively. The authors applied naive Bayes as one of the machine learning algorithms for predicting students' grades based on previous course performance records. And the third model was supportive vector machine. It is a supervised learning algorithm used for classification and regression analysis. It works by finding the optimal hyperplane that best separates the data points into different classes. So the authors mentioned that supportive vector machines was chosen based on its ability to handle classification problems successfully, particularly in scenarios with decision boundaries that are not nearly separable. And another one was k-nearest neighbor, which is a non-parametric lazy learning algorithm used for classification and regression. It classifies data points used on the majority class among their k-nearest neighbors in the feature space. The authors employed KNN for predicting students' grades, mentioning its suitability for small feature datasets and its reliance on a distance function to calculate similarity between instances. They also used logistic regression, which is a statistical method used for binary classification problems. It models the probability of a binary outcome based on one or more predictor variables. So the authors used logistic regression as one of the machine learning algorithms in their predictive model, leveraging its ability to analyze categorical data and understand the relationship between the variables. They also used the random forest to predict students' grades, mentioning its in handling high dimension data and preventing overfitting. So the approaches for model evaluation, they used accuracy, precision, recall, and F measure. So accuracy was calculated using a formula that considers the number of correctly classified instances divided by the total number of instances. Precision was calculated for each class individually using a formula that considers the number of true positives predictions divided by the sum of true positives and false positive predictions for each class. So the recall was calculated for each class individually using the formula that considers the number of true positive predictions divided by the sum of true positive, false, negative predictions for each class. So the F measure was calculated using a formula that combines predictions and recall, emphasizing the model's performance in correctly identifying positive instances while minimizing false positives and false negatives. The thought processes of the paper by the authors was identifying the problem, selecting machine learning models, data processing and feature selection, model evaluation and performance analysis, interactive approach and experimentation to develop an effective predictive model for students' grade prediction. So the strength and weaknesses of the models and evaluation metrics. The strengths were high accuracy achieved by some models, ability to handle imbalanced datasets, visualization of classification performance, and the weaknesses were impact on imbalanced data on model performance, limitation of certain algorithms in handling high-dimensional data. So these are some of the visualizations which were used. This is the framework of the proposed multi-class prediction model for predicting final students' grades. And this shows this table here is showing the mean and standard deviation of students' final marks and grade achievements according to the course taken. The students' final mark were calculated based on this table. So we also had a flowchart for the proposed multi-class prediction, as you can see here, with the databases and the flow of the information according to the journal paper. We also have a graph plot of students' final marks distribution. We have comparison of correctly classified by class without applied SMOTE and comparison of correctly classified by class with applied smooth. As you can see the difference, this is with applied smooth and this is without applied SMOTE. We also have the mean and standard deviation of students' final marks against students' final grades achievements according to the taken courses. We have comparison of accuracy and F measure of proposed SFS model. We also have analysis of average grades point, trend for ICs and CSA courses by yearly basis. Thank you very much.